Dry saturated steam is supplied to a steam turbine at 12 bar, and after expansion its condenser pressure is 1 bar. That is, a dry saturated steam is given to a steam turbine at state 1, which is at 12 bar, and its expansion and after expansion its condenser pressure is 1 bar. That is, at state 2 the pressure remains 1 bar. Find the Rankine cycle efficiency and specific steam consumption. We have to find the Rankine cycle efficiency and specific steam consumption with this given data and neglect the feed pump work. The feed pump work which is given to the steam power plant is being neglected. Okay. Therefore, from the given data at point 1, the pressure is equal to 12 bar, and due to this expansion process work is being produced and the pressure reduces from 12 bar to 1 bar at state point 2. Therefore, the pressure P2 is equal to 1 bar. Okay, this is the given data. You have to note that the pressure at point 2 and point 3 are equal since it is a constant pressure process. That is, the condensation process is taking place at constant pressure. Okay, therefore, the pressure P2 will be equal to P3. The pressure P2 will be equal to P3. One thing you should notice that this is the critical point, and the left hand side of the critical point is the saturated liquid curve and the right hand side is the saturated vapor curve. Therefore, at point 2, the steam is in vapor state, and due to the condensation process, the phase change is being carried out, and at state 3, it is in a liquid state. Okay, this you should keep in mind. Though the pressure may be same, the at point 2 it is in a vapor state, and at point 3 it is in a liquid state. Okay, with this given data we have to find the efficiency of the Rankine cycle and specific steam consumption. Okay, the efficiency of the Rankine cycle is given by the equation H1 minus H2 divided by H1 minus H3. We have to find the value of H1, H2 and H3. That is the enthalpy at these three states. The value of H1 can be found out from the steam table, and I have noted the values of the enthalpy and entropy at 12 bar and 1 bar from the steam table. And since H1 is the state point 1 and the pressure is 12 bar, the value of Hg and entropy is being taken at pressure 12 bar. Therefore, the value of Hg is equal to the value of Hg which is taken from the steam table is equal to 2784.7 kilojoule per kg. We have this value, that is enthalpy of the gas at state 1. And this enthalpy of the gas is equal to H1 since it is a dry saturated steam where X is equal to 1. Therefore, we have the value of H1. And in the same way, the value of S1 will be equal to Sg, which is equal to 6.523 kilojoule per kg Kelvin. So we have the value of H1 and S1. With this, we have to find the value of H2. And H2 is given by a equation, that is H2 is equal to HF2 plus X2 into HFG of 2, where HF is the enthalpy of the fluid and HFG is the enthalpy of vaporization, and X is nothing but the dryness fraction. Okay, with this data we have to find the value of enthalpy at the state point 2. We have the value of HF2 and the value of HFG, but the dryness fraction value remains unknown. We have to find the dryness fraction value in order to calculate the value of H2. This dryness fraction value can be found by equating the values of the entropy. That is, since the expansion process is taking place isentropically, the value or the entropy at state point 1 will be equal to the state 2. That is, S1 will be equal to S2. Since the expansion process is isentropic, S1 is equal to S2. From this, the value of x2 can be calculated by an equation, that is S1 equal to S2, which is equal to SF2 plus x2 into SFG of 2. Okay, this is the entropy equation. From this, we have the value of SF2, that is at 1 bar, we have calculated the value of SF2 and SFG of 2, that is both the entropy of the fluid and the entropy of vaporization at state 2 is being taken from the steam table, and we have this both the value and the value of S1. Since the value of S1 and S2 are equal, we have this value too. Therefore, the only unknown value is x2. So we can find the value of x2, that is dryness fraction at state 2, from this equation. Okay. Therefore, the value of x2 can be calculated as S1 is equal to 6.523, which is equal to SF2 is equal to 1.3026. SF2 is equal to 1.3026 plus x2 into SFG is taken as 6.0568 kilojoule per kg Kelvin, and SFG of 2 is 6.0568. Okay. From this, the value of x2 is calculated as 0.86. That is, the dryness fraction at state 2 is calculated as 0.86. Now, we can substitute the value of x2 in this equation in order to find the value of H2. Okay, if you substitute the value of x2 in this equation, we already have the value of HF2 and HFG of 2, and there were two unknowns, that is H2 is also unknown and H2 also unknown. We have found out the value of H2, and by substituting these values you can find the value of H2. So by substituting these values, you will be getting H2 is equal to HF2 plus X2 into HFG of 2. Okay, by substituting this value, we have HF2 as 417.4 and X2 as 0.86 into HFG of 2 is 2258. And from this, the value of H2 is being calculated as 2359.28 kilojoule per kg. Okay. Now we have find out the value of H1 and H2. The value of H1 and H2 we have find it out. Now we have to find the value of H3. Okay. Now we have to find the value of H3. And this value of H3 is equal to HF2. That is, the value of H3 is equal to HF2. That is, at state point 2 and state point 3, the pressure remains constant. Okay. Therefore, the values which you have calculated for state point 2 will be equal to the state point 3. The only difference is at state point 2, the steam is in a vapor state, and at state point 3, the steam is in a liquid state. That is, will be a phase change which has been taken out. Therefore, the steam is being converted into water. Okay. Therefore, the value of H3 can be taken from the value of HF2. Therefore, both the values will be equal. That is H3 is equal to HF2. Okay. Now we have all the values to find the efficiency of the Rankine cycle. That is, the efficiency of the Rankine cycle is given as H1 minus H2 divided by H1 minus H3. Okay. From this, we have the value of H1 as 2784.7 minus 2359.28 divided by, and the H1 value is again 2784.7 minus H3 is equal to HF2, and the value of HF2 is 417.7. From this, the efficiency of the Rankine cycle is calculated as 0.1797, which is equal to 17.97 percentage. Therefore, we have calculated the efficiency of the Rankine cycle. Next, we have to find the specific steam consumption. Okay, next we have to find the specific steam consumption. The specific steam consumption is given by an equation which is 3600 divided by the work done, which is nothing but 3600, and the work done is by the turbine, and this value of W is equal to H1 minus H2. That is, the work done by the turbine is given as H1 minus H2. By substituting the value of H1 minus H2 in this equation, you can get the value of SSC. That is, specific steam consumption is equal to 3600 divided by the value of H1 is 2784.7 minus 2359.28, and the specific steam consumption is equal to 8.46 kilogram per kilowatt hour.